Hello, everyone. Welcome back. We're going to finish off the 8.1.2 notes today. So, kind of a short section, but this last piece is kind of a cool thing to look at as far as learning how to get more accurate with those curve sketches that we talked about the other day. All right, so we're going to talk about x-intercepts and how the behavior of our polynomial changes at different x-intercepts throughout our polynomial. Okay, so we're just going to kind of go through this just as the notes describe here. So we're going to be taking a look at polynomial 1, and we can see our factors. We have x minus 2 and we have x plus 5. All right, and the x plus 5 is being squared, so there's actually two of them. And what that means is that this particular factor, this x plus 5 squared, has something called a multiplicity. And its multiplicity is 2 because it's got an exponent of 2 on it. Okay, so when you get to MyOpenMath and you see some problems and it says something about multiplicity, what they're describing is how many times is it that that factor occurs. So if it had an exponent of 3, it would have a multiplicity of 3. If it had an exponent of 4, it would have a multiplicity of 4. Okay, so the x plus 5 squared is a factor. And this squared factor produces what is called a double root, or a root with a multiplicity of 2. Okay, and what they want us to do is they want us to go ahead and graph this particular function, and we want to take a look at the x-intercept. We want to look at the -5 root, okay, on the graph. So I've got that already done in Desmos, so I'm going to switch over to Desmos. I have plotted the x minus 2, x plus 5 squared, and I'm able to look at it over here, okay? So this is the root. This is the -5 that is occurring here. This is the root of 2, right? So we had a root of -5 and a root of 2. This one has a multiplicity of 2. This one has a multiplicity of 1, okay? And you'll see, like, when we look at this polynomial over here at the 2, the polynomial comes up, it passes right through the x-intercept with no issues, right? It just passes right through. But over here at the -5, the polynomial comes up, it hits the -5, and then it goes right back down. Okay, and what we call this a bounce, right? The polynomial comes up, bounces off the -5 and goes back down, and then eventually it has to turn and come back up to hit the root at +2. Okay, these bounces, they occur when we have different multiplicities. Okay, so these bounces don't occur. If we have a multiplicity of 1, that polynomial is going to pass right through, no issues. But when we start increasing the multiplicity of a root to like 2 or 3, weird things start to happen. Okay, so let's go back to our notes. And we did this part. We observed what happened at the x equals -5 root. We saw a bounce. And I'm just going to note that down here, right? We saw a bounce. So then they want us to take a look at this new polynomial. So we've got this one right here. Notice that we have another polynomial here, or another factor that's got a multiplicity of 2. This one has a multiplicity of 2, and they specifically want us to observe what happens at that root. Let's see if we see the same behavior. Let's see if we see a bounce again. So I'm going to go back to Desmos. I've already got the polynomial entered here. So I'm going to turn off the first one. I'm going to turn on the second one. And let me click on that. Makes it a little bit thicker and easier to see. Right? And we're trying to pay attention to the root at x equals -3. So that's this one right here. And I'll zoom in a little bit on it here. Okay. So we can kind of see, again, we see that bounce, right? It comes up, it hits -3, goes right back down. The other roots all have a multiplicity of 1, and we see the pass-through. It just goes right through with no issues. But when we have that multiplicity of 2, we have that bounce. And as it turns out, we're going to see this behavior of bouncing anytime the multiplicity is even. So if it were a 4, 6, and 8, we would see that. In fact, let's change that to a 4. Let's see if I can get up there and change that to a 4 so you can see what it looks like when I change it to a 4. So let's say we have a multiplicity of 4, and there it is. You can kind of see it right there. Same bouncing behavior, but it's flattened out a little bit. right? And I can change it to a 6 so I can keep increasing it. And you can see it flattens out more and more and more, but we're still seeing that bouncing behavior. Okay, and there it is with a multiplicity of 8. I'm going to put it back to what it was supposed to be. And again, when we saw that x equals -3 root there, we saw another bounce. Okay. All right, so, and this is where they kind of want you to make that observation. What did you notice? What do double roots look like when they cross or touch the x-axis? They bounce. When the multiplicity is even. Right, and they want us to sketch an example of this below. So I'm just going to draw something like this. Like here's my x and my y-axis, and I'll draw an example of a bounce. So this is what a bounce would look like, right? We just want to have that in our notes for future reference in case we see that behavior again. It might help us out. So we're going to move on to this next one. So again, new polynomial. And notice this time we have a third degree polynomial. Okay, so this one has a multiplicity of 3. They also refer to this as a triple root. Okay, so that x plus 4 cubed creates a root of -4. So we say -4 is a triple root. And we want to know what it looks like when it crosses or touches the x-axis. We want to know what behavior it is we're supposed to see when we have a multiplicity of 3. So I'm going to go back here. I'm going to graph that function that they gave me in Desmos, and I'm going to take a look at it and see what it looks like. So I've got it typed in here. I'm just going to turn it on, and we're looking at the root at -4, and that is right here. So let me pan over a little bit. Okay, so we have another root over here, but it just passes through. That's just because the multiplicity of this x is just 1. There's only one of them. This one has a multiplicity of 3, and we do see kind of a weird behavior going on here. It passes through, right? It doesn't do the bouncing action that we saw with the even multiplicities, but it still passes through, but it flattens out as it goes through. And we call this an inflection. So as it passes through the -4, it inflects. So it flattens out, and then it starts to rise again. Okay, so we call that an inflection point, and that's what happens at a triple root. And this will actually happen at any odd multiplicity root. Okay, so for instance, if I were to change this to a 5, we'll see the same behavior, but it flattens out even more. Okay, so if I were to change this to a 7, we'll see the same behavior, but it will flatten out even more. Okay, same thing if I were to change it to a 9. Right, so you kind of see what happens as we pass through those roots. It's an important behavior that we like to observe, so we want to add this to our curve sketching ability. So we're not creating super accurate graphs, but we want to make sure that we get the behavior down correctly, and these are important features of the behavior. Okay, so let's see here. So at triple roots, we see an inflection. Okay, and I'll draw an example of this for my notes. And let's say pass through, right? Pass through, and then we'll do a little inflection here, just like that. Okay. So this point right here, that's our inflection. So it's still passing through, but it's different than when we pass through here and here. This just passes through without any change in behavior, but here we have that inflection or that flattening out when we have a triple root. Okay. Let's see, we got, all right. So that's pretty much all I needed to cover. I would try out some of the practice problems and see how you do there. If you have questions, you can always post them in the forum. Also, take a look at the discussion forum today. It's going to give you a good graph to think about when it comes to this triple root and double root stuff. Okay. All right, guys. Have a good day.